Hi, my name is Victoria and I will be your virtual tour guide today. This tour will take you through 3 different stops in the world. These stops are known to have various types of atmospheric, lithospheric, or hydrospheric patterns that I'm going to go over with you. Let us begin with our first stop. Our first stop takes place in Honshu, Japan. Japan is home to the hydrospheric pattern we know as tsunamis. Tsunamis are gigantic waves that are triggered by a type of seismicity, like an earthquake or volcanic eruption. There is a high correlation between seismicity and tsunamis in this region. Because of its location by an undersea fault line, Japan receives a lot of seismicity that creates these tsunamis. Let us begin by taking a closer look into Honshu, the main island of Japan. While we take a look at the coastline, we can see that the coast of Honshu is heavily populated. Because of this and the high risk of tsunamis occurring, Japan has implemented a tsunami warning system that allows these high-risk areas to be evacuated ahead of time. This is probably the best solution in preventing loss of life during a tsunami. Another benefit would be to build safety shelters or change building codes so that people are protected from tsunami damages. These are both things that Japan has already implemented, leading this country to be the most prepared place in the world. Next, we will cross the Pacific Ocean to the state of Alaska. Alaska is located along the Ring of Fire, which is the most volcanically and seismically active area in the world. Alaska is where we will find our example of lithospheric activity. This volcanic activity is due to Alaska's location by an oceanic continent convergent boundary. Here, the oceanic crust subducts under the continental crust, causing magma to rise and create volcanoes. These subduction zones are areas where crust is being recycled back into the earth. Let's take a look at Katmai National Park, home to the Valley of 10,000 Smokes. Here we can see the various mountains and volcanoes that reside in the national park. Like I said before, these volcanoes are created due to magma rising from the subduction zone on the convergent boundary. Thankfully, this region is pretty isolated, so there isn't as much damage caused by the volcanoes. The volcanoes do cause fires by igniting vegetation and create smoke and ash in the surrounding area. To prevent any harm to the people, it would be best to implement a disaster plan as well as an evacuation plan. The government should provide disaster equipment in case of a volcanic eruption. On our final stop, we will head towards the United States, towards Oklahoma. Oklahoma is located in the region known as Tornado Alley, where we will find our example of atmospheric activity. This area is prone to tornadoes because it is in the location where cold, dry winds from the north and warm, moist winds from the Gulf of Mexico meet. This causes a funnel cloud to form and create a tornado. This area is also prone to tornadoes because there is no mountain range to stop the different winds from meeting in the Great Plains. When we take a closer look into Oklahoma, we find that one city is affected by tornadoes more than others. This city is known as Moore. The city of Moore is no stranger to tornadoes, for many tornadoes touch down near the city. These tornadoes cause massive damage to the city and its people. Tornadoes can have thunderstorms that occur with them, and depending on their strength, they could carry houses and large objects through the wind. There isn't much of a warning system for tornadoes. People are given a 13-minute warning to find shelter. In the future, to prevent loss of life, it would be best to try and advance our warning system. We should also attempt finding a better way to build houses so that they are not swept away by tornadoes. In the future, we will hopefully have a plan to prevent further loss from these natural disasters. But for now, we can strive to make advances into understanding more about these phenomena.